So it's time now to combine the two weights that we've developed. Okay, that is, it's time now to come up with a scoring scheme that is going to satisfy, that is going to resolve both these difficulties with the Jacquard scoring that we talked about earlier. And the way we'll do that is we'll take the scoring scheme that we developed to handle this and the scoring scheme that we developed to handle this, which was IDF, and just multiply them together. Okay, and that is called the TF-IDF score. Okay, it's the term frequency dash IDF score, which combines both the term frequency score that we developed and the IDF score that we developed into a single score by multiplying them together. Would you please turn off the microphone? Yeah, thank you. So the TF-IDF weight of a term in a given document is the product of its term frequency weight. Okay, and the term frequency weight is log of 1 plus TF, and its IDF weight, which is this particular weight. And this is the best known weighting scheme in information retrieval. Okay, so TF-IDF is like it's used very commonly in companies that work on IR systems. It's like using the word. It's like a stop word almost. If you look at the lingo of IR people, they use IDF almost like a TF-IDF almost like a stop word. It's that common. So um, note that the dash here is not a minus sign, it's just a hyphen. And other ways of denoting this score are TF dot IDF and TF cross IDF. So what happens if, let's look at the intuitive behavior of this score. As you can see, when the term frequency increases, the score is also going to increase. Okay, and that makes sense. It makes sense that this score is increasing with the number of occurrences of terms in a document. Okay, and that's what we wanted over here. Okay, we wanted to incorporate how many times a term occurs in a document, and the TF-IDF score does that because you have this log of 1 plus TF in it. It also increases with the rarity of the term in the collection. Okay, and the rarity of the term is indicated by the IDF part of the score. Okay, now you can see why you need at least two terms, because if there's only a single term, then this value will be constant. Okay, and if this is a constant, then the only thing that will distinguish different documents from one another will be how many times that single term occurs in various documents. Okay, the IDF comes into play only when there are two different terms in the query, right? Because for those two terms, the IDF score will be different. Now, how do you actually use the TF-IDF to compute the overall score between a query and a document? Well, you just add the TF-IDF score for every term in the query. Okay, just like before. And there are variants of the TF-IDF score. Okay, again, based on whether we would, we discussed this earlier, whether we just go with TF or whether we go with 1 plus log TF or we use some more complicated formula. Okay, so the first component of this score can be expressed using different formulae. This is just one of them. Similarly, the second component can also be expressed in different ways. So let's look at an example. Going back to the count matrix, recall that we converted the term document incidence matrix into a count matrix, and the count matrix was storing the term frequency values, right? If you recall, we discussed this before the break, that each document in the count matrix can be thought of as a vector of natural numbers, right? Where the value of every component of the vector is the term frequency. Now we can think of another matrix called the weight matrix, where instead of using the term frequencies, we use the TF-IDF scores. Okay, every entry in this matrix, in this weight matrix. Okay, let's look at this particular entry for example. This is the TF-IDF score between this term and this document. Okay, this is the TF-IDF score between this term and this document. By the way, what happens to the TF-IDF score when a given term does not occur in a given document? Let's say a given term in the query does not occur in the document at all. What will be its TF-IDF score with respect to that document?
So, will it be zero by any chance?
Yeah, it will be 0. Why will it be 0?
Because it says TF into IDF. So,
Mm-hmm.
uh, it's in one. If one is zero, naturally the product will be zero, right?
Yeah, yeah. So because TF is 0, log of 1 plus 0 is just log of 1, which will be 0. And so 0 times this is also going to be 0. So if a given term does not occur in a given document, then the TF-IDF score is going to be 0. That is, this term, we are not giving any weight to the occurrence of this term in the document. That's what this means. And what if the term occurs in every single document? What will be the TF-IDF score then? Intuitively, how much weight do you want to give a term that occurs in every single document? You don't want to give it any weight, right? Because that term is, I mean, no document is going to be ranked closer to the query just based on that term, because it, it's appearing in every single document. So what will be the score here, the TF-IDF score? What will be the value of the document frequency for a term that appears in every document?
And it'll be n.
N.
Document frequency will be n,
Yeah. So log of n by n is just log of 1, which is
which will be
0.
0.
Yeah, just as we saw here, right? This is what we saw. A term like the appears in every single document out of these million. And so the IDF score is 0. And so the TF-IDF score will also be 0 for that term. So in the in this weight matrix, these zeros you see could either indicate that this term does not occur in this document, or it could indicate that this term occurs in every single document, in which case, well, in this case there is no example of that, because there you would have every single score in this row to be 0. If there was a term like the, which appeared in every single document, then you would have seen zeros everywhere, because the IDF score does not depend on the document itself. It just depends on the term, how common the term is in the collection, as indicated by the document frequency. And if the document frequency is n, then that IDF score is going to be 0, regardless of what document you look at. Okay, this is a subtle, I mean, not a subtle point, but it's something you may just want to note, that the TF score depends on uh, the TF score depends on both the term and the document. So for a given term and a given document, there is a term frequency. But the IDF score just depends on the term, because the IDF score is determined just based on the document frequency for that term. But of course, because we are combining both of these, the overall weight will be dependent on both the term and the document, because this component depends on both the term and the document. Even though this one just depends on the term. So because this one just depends on the term, when we plot the IDF scores, that will be the same for all documents, across all documents, for a given term like this. And so the TF-IDF scores will also be 0, because it's the product of the TF score and the IDF score, and the latter is 0. So in this weight matrix now, you can think of the document as represented by a vector of TF-IDF weights. Okay, and now each component of this vector is going to be a real number. So it's r to the power, I mean, this is just a set theoretic notation indicating that every document is a vector of length v, where v is the size of the vocabulary, and each component of the vector is drawn from the set of real numbers, positive real numbers in this case. Okay, so what we're going to do is we are going to visualize these vectors in a v-dimensional space now. Okay, we're going to try to think about them diagrammatically. So imagine a v-dimensional space. Okay, of course you can't imagine a v-dimensional space for v greater than 3, but in an abstract way, just think of a v-dimensional space, a v-dimensional vector space, where each dimension corresponds to a particular vocabulary term, right? Because the length of each vector is just the number of vocabulary terms here. So each term is like is defining an axis in that multi-dimensional space.